All right, folks. So today we're just going to be looking at the periodic table. Periodic table does look like that. And of course, there's a bunch of different elements. And these are the basics of everything you find in the universe. So every piece of matter, everything, your table, plastic cups, everything has this stuff in it. Whether it be pure, like pure hydrogen or pure helium, like you might find close to pure helium, like in a balloon or something like that. You might find, pure carbon like in a diamond or something, and none of them are truly pure. There's obviously some stuff stuck in there, but pretty pure. Copper, like when you get like a nice pure copper coin or copper pipes for plumbing, they're pretty pure copper. It's almost all copper. And a silver coin or a gold coin right here, AU. So when things can be pure and in its element state, in other words, um, you have the element itself. But in most cases, almost everything you find on a day-to-day basis is multiples of these combined together to make a compound of sorts, or like a molecule where you have a couple of these combined together to make something new. For example, like, you find water, and we all know water is H2O. In other words, it's two H's and one O, one oxygen. So, like I said, you can combine these and make all kinds of stuff, and everything you find in the universe is pretty much here. Um, but like I said, it can be combined to make larger molecules, which are very stable and almost act like its own little thing. But technically, if you look closer, it's actually just multiples of these combined together, like water. Water is a good example because it just seems like water is water and there's nothing else to it. But if you look close, it is hydrogen, oxygen, and it could be split apart. You can use electrolysis and electricity and pull those hydrogen oxygens apart and break them apart. So you could do that. Um, now, how do you read these? So if you look at one of these, like this one right here, it's hard to see that one. It's a little far away. So let's go over here, and I have this one right here, a little closer. There's obviously an atomic number. We'll talk more about that later. It actually just means how many protons are inside the element. The symbol right here is O for this particular element, and its name is oxygen, and its atomic weight is this. We'll talk more about this too, and what this means. We're not going to do that in today's lesson, but just know that this is the atomic weight of that thing, and technically, the higher this number, the more heavier it would be, more or less. Um, and the name, the element symbol, and the atomic number is pretty much all you need to know for today. One other thing, though, is if you see this in parentheses right here, that usually means, like on most periodic tables, that's man-made. For example, if we go over here to the periodic table, if you look, and it's kind of hard to zoom in here. Oops, I just zoomed back in. Um, if you look, and it's hard to see right here, even with my eye, that that all the numbers tend to be larger and larger and larger. And the very last time you find one, every once in a while you find a man-made fill in the blank here somewhere. But the very last one, and if you go down here, by the way, you see these two little spots right here? These are inserted here. Okay? Otherwise, this periodic table would be too messy and it would be outside this this nice poster size thing. So this big long strip right here, these two colors, actually get inserted here, and this part becomes much longer. So if we go and these numbers get bigger and bigger, here we are in the 60s, and then we're in the 80s here, 90, 91, 92, 92 being uranium. At looks like it says the atomic mass is 238.03. It's hard to read it there. But that one is not in parentheses. The very next one is in parentheses, and everything after that is in parentheses. So the very last element that you can actually find, the biggest element or the last element on the periodic table that you can find in nature, just like, dig it out of the ground and find it, would be this one, uranium. All these other ones are man-made and unstable. And they can be made, and they're usually byproducts of other ones out here, but they themselves, you just don't dig them up and find them. And they kind of have to be made. So that's pretty much it for this periodic table. What other things you need to know is when you find a number, if you find a name, you can find a number associated with it. And like I said, that's the atomic number. And we're going to learn a little bit more about all these, like in how they're organized. You notice there's a lot of colors and whatnot. We're going to learn more about that on the next lesson, so that you can figure out that these are all related. And one way I can show that real quick before I even go too far here is this little strip right here. This little strip is all related. Copper, gold, silver. Sorry, copper, silver, gold. And it's kind of weird that those are all precious metals. We tend to make coins out of all these, and also they tend to be more valuable as you go down. Copper is kind of pricey, but then even more expensive is silver, and even more expensive than that is gold. So, that's kind of a coincidence, but at the same time, it's the way this periodic table is set up, is to is very interesting, and there's a lot of different properties here to share. So anyway, we'll get to that later on. I don't want to go too deep into this. Today, you should know what chemistry is itself. What is chemistry? And chemistry is the science that deals with the properties, composition, the structure of substances defined as elements and compounds, the transformations they undergo, and the energy that is released or absorbed during these processes. So it's pretty much all of the elements and the compounds that they make and the transformations that they can undergo, like when they maybe go from liquid to solids, or when you burn them and they turn to a gas and they release heat, like when you set a fire, right? It releases heat. That's part of chemistry. Or there's also ones that absorb energy and make cold. You guys might have seen those where you break those little packets, little bags, and you pop them, and they turn really cold. They're like ice packs for like sports. Those ones actually absorb heat, so thus they feel really cold. They're sucking the heat out of, like, wherever you lay it. So you lay it on your shoulder, it's going to suck the heat out of your shoulder. It's absorbing it, so it gets cold. So that's chemistry. And I think everything else you need to know for today's activities on your worksheet is pretty much I explained here on the periodic table and on how to read this right here. Okay, so that's it.